Yeah, we're going to be doing weekly spaces at minimum. I think, one thing we want to do is just keep people updated on what we're doing. Obviously, building in public is a prerequisite for that. And it's Thursday right now. We've already had, quite a few interesting meetings this week. That's one really fun thing about building this project is just the amount of people that we talk to. It seems like almost every day at this point that are either interested in the project or trying to learn more about the project, whether it's implementation or partnership or whatever. We're just having a lot of fun fielding those calls and figuring out, where the technology is going to fit best and who we can align with. I think, Tsotchke, we could probably talk a little bit about our opportunity with what it's going to look like to bring the QRNG on chain, because that was one of the more interesting meetings that we had this week was with someone who is very plugged into Solana as a whole, has a lot of great connections to Solana as a whole, and their main interest in our conversations was bringing our QRNG on chain so that our technology actually is integrated into Solana. And that's something we've been looking at for a while now. So, that's an ongoing thing and we're actively working on that. But Tsotchke, if you want to talk a little bit about maybe a high level overview of that and kind of what our possibilities are there, that I think would be great.
Yeah, sure. So as many of you realize, we've had a sort of quantum-inspired random number generator available for quite some time. So this is a semi-classical sort of emulation of a sort of entangled superimposed state that we use as a number generator for producing non-deterministic output. We have been serving that via an API for quite a long time now at api.tsotchke.net, and many people have used the service and are using it in their applications now. But something that we've been interested in basically since December is the concept of actually bringing these random numbers to the chain so that they could be used in things like contracts or in transactional signatures, or as part of generating data, or just to feed some other process or contract or something like this. So we will be bringing a service without going into too much detail, because we're still kind of considering whether or not certain technical limitations are going to apply to us, being that we want to be able to generate non-deterministic random numbers on a deterministic Turing-complete chain. So we are exploring the possibility of actually hosting our WebAssembly version of the QRNG on chain, or if that is not going to be possible due to certain technical limitations, we will be hosting it as an oracle that can be used in various contracts or other services. And that's going to be sort of a permanent utility that we set up that everyone can utilize. It will utilize the Solana currency, and it will be compatible with various projects and various offerings. It's something that we've been very interested in as a way of sort of strengthening the ecosystem, but also sort of finding applications of our technology that offers sort of immediate utility to the blockchain. So that will be coming very soon. We don't want to put a timeline on that exactly, but in the next little while, we will be bringing that service forward. So we'll be giving you more information as that unfolds, but you can look forward to that.
Yeah, we don't want to dive too much into that. Just like you said, we're kind of figuring out from a technical standpoint what some of those things will look like. But either way, super exciting to think about what that'll mean. I think our kind of narrative from the beginning has been like, we want to be the leader in this next quantum revolution. And I think, using our technology to integrate into Solana is going to, I think, open a lot of eyes. There aren't any other projects that are doing that right now. So that puts us in a good position to be a leader for this ongoing AI revolution that we're experiencing. I mean, I think, a lot of people are realizing that AI is so much bigger than crypto, and it's trickling down. And so, much like Formula One technology, that kind of is the top of the line in terms of cars, and that technology then trickles down into standardized vehicles. We're kind of seeing the same thing happen right now with AI, then trickling down into crypto. And that's where we're hoping to help accelerate that. So, looking forward to that a lot. Other thing, Tsotchke, you might be able to update people on is the minced portion of your Tensor library, because that's obviously a huge development as well that was relevant to this week.
Yeah. So in general, there's sort of a misunderstanding about what the nature of the quantum geometric tensor library actually is. And that's understandable because there are very few projects that are similar to it, and there are very few offerings on GitHub that are even trying to cover the same scope. So many people are aware that the library itself is a quantum computing framework that is to be used on real hardware, including IBM, Rigetti, and D-Wave, with expanding support for companies like IonQ and other offerings from companies like Xanadu are planned in the future. But it also includes a fully featured semi-classical quantum emulation, so you could perform all of the same, well, not all of the same, but many of the same circuitry operations on a classical computer. So one of the core sort of aspects of the library is this sort of back end, both semi-classical and fully hybrid quantum classical supercomputing framework, but it also supports multi-vendor support as well. So that's sort of the back end computing side of the framework. The other part of the framework that tends to be overlooked by most people is actually the learning framework. So it's called the Quantum Geometric Tensor Library for a reason, and that's because the principal object of the library is a quantity or an object referred to as the quantum geometric tensor. So aside from one other framework that is for computing like simulations of quantum many-body systems called NetCat, we are the only other open source project in which you can even deploy quantum geometric tensor, and actually one of the few proprietary products as well, if not the only one. And that tensor, as I mentioned, being the central object of our learning system, is really the subject of key importance. So this demonstration that we will be releasing very soon is called MINST, or MNIST, and it is a handwriting recognition demo that's usually sort of given as, some people refer to it as the Hello Computer of deep learning or of statistical learning systems. Effectively, the library now, the entire core of it compiles. So all the core utilities relating to quantum gate operations, but also the curved sort of surface topology, and the geometric invariance and the preservation of quantum states in the tensor. That's all implemented and compiles. And so one of the sort of killer demos of that library would be a learning demo that shows our library succeeding and actually outperforming most approaches, including custom tailored approaches to solving this particular problem. So for this particular exercise, there are 10 digits from 0 to 9, and they are drawn by hand. And the job of the program would be to sort these handwritten drawings based on what number they are. So that is one of the demos that will be shipping very shortly. So the reason why it's such a great example of the capability of the framework is because it's sort of a specialized learning problem that you solve with, a generic learning framework, i.e., our Tensor library. So from there, it demonstrates that not only is the entire pipeline operating, but we're handling, quantum states appropriately, and we're solving real problems in an accelerated fashion over other approaches. So beyond, just Minst itself would be something like CFAR, which is a kind of a text caption and image classification sort of a problem. So sort of a classic problem in the beginnings of studying language models and vision models and stuff like that after you successfully solve something like handwriting recognition would be a basic image and caption sort of classification problem. So the next demo after Minst will be CFAR, and then after that we'll release the sort of the specialized framework extension for training LLMs on top of the library, along with relatively small parameter quantum emulated QLLM. So I'm still sticking to my self-imposed deadline to release a QLLM before the end of the month. I'm hoping that we're going to reach that. It seems like we're on target, so everything should be okay. But it would be sort of a stretch goal then to hope that by the end of the month we'll actually be running the system on some real quantum hardware so that we could release, say, in addition to the semi-classically trained QLLM, a truly quantum trained QLLM, but I don't know if we're going to have the capability to do that prior to the end of the month. But the library is coming along very nicely. Most of the core utilities are working correctly. And the next, probably not the next iteration, but probably the iteration after that will include the proper build system with all the benchmark testing and stuff like that automated, so you could just run a single script to run the entire build process and build the demo applications and samples and stuff like that. I just ask everyone to bear with me because it is quite an endeavor to build a project of this magnitude. And a lot of what I spend my time on is sort of hyper attenuation of the sort of algorithmic processes. So I'm always looking for better ways to optimize, but also to make sure that the system itself is working with the minimum number of steps and the least amount of wasted energy. But I'm very happy to say that the Minst test compiles and runs very well. It's very efficient, even running on CPU. Admittedly, I'm building it for the Apple Accelerate framework on my Mac, but I'll try to make sure that the binaries ship for relatively generic CPU operations, so all of you can build it on your own Unix-based machines.
Yeah, I was actually going to ask you too. I mean, a lot of people wonder what are the actual integrations or like applications going to be, when the LLM is, able to be built on. And it's like, we actually talked, you've talked extensively about the robotics stuff, which is interesting because we did also field a robotics call this week with someone that's got a robotics company. And we're talking about, what that might look like. But robotics, animation was the other thing that we've been talking a lot about. So like, I think a lot of people maybe don't understand how that actually translates. So can you maybe talk a little bit about either robotics, if you want to dive into that, or even the animation use case? I think is super interesting as well.
Yeah, so many people are aware that are learning models. So not just the QLLM. We tend to talk a lot about the QLLM, but there are actually many learning utilities that we're developing on the Tensor library itself, such as 3D geometry generators. So things like mesh, and recently someone sort of challenged me to develop a system that outputs really good parametrized geometry. So I can't promise we're going to do that in the short term, but very interested in utilizing sort of the geometric properties of our system to be able to generate really good like geometry that's potentially usable in CAD systems or 3D printing or anything just beyond like, simple mesh applications. But one of the things that I think people realize is that our models are about 10 times smaller. That's a good sort of a back of the envelope calculation. Our models are about 10 times smaller than equivalent sized models. So the benefit to that is being able to run them on machines that have significantly fewer system resources, such as RAM or hard drive space, or whatever CPU clock time or something like this. So our few people who are not really paying close attention to the project realize this, but a lot of the interest um, in developing these technologies is actually directly to benefit and to help improve the robotics industry. That's actually one of my big passions is robotics, personal robotics, industrial applications, and other applications such as social or military or just various forms of convenience or something like this.
Well, let's
And
talk about that for a second, right?
yeah,
Because I
sure.
think, the other part of this that I think a lot of people, it just takes time to understand how this all ends up trickling down. But like, basically, to lay it out in simpler terms, whether it's a robotics company or, a smaller video game company, a large video game company even, or, a military application, basically, I think what you're saying is like, allowing these companies to use your framework, which is about 1/10 of the size, is going to save a ton of money. And so then being able to save money is going to allow a lot of people that otherwise wouldn't be able to build these applications because it is so expensive. I think you gave me a number once that it was like, was it $100 million or something like that? Yeah, 100 million to train GPT-4. So if we're 1/10 or 1/20th the cost of that, suddenly we have all these companies that are going to want to be using your framework. And that then ties into this kind of flywheel mechanism that we've talked about, right? Because where this starts to become a pro revenue company is that people are going to be paying us and Tsotchke to use his LLM framework. And it's going to be very cheap for them to do so rather than using something large like GPT-4. That flywheel mechanism is basically what we're looking at, because if they're having to pay to use the LLM, then a percentage of that can go back into Tsotchke as the coin itself. And I think there's some interesting conversations within that alone.
Yeah, Zach, you brought up so many excellent points all at once. So yeah, I'll kind of go backwards a little bit through what you were saying. Yeah, so one of the most immediate applications of the token. So we get questions all the time, like, what is the actual utility of the coin? How does it tie to the company? And to be honest with you, we had some reticence sort of answering that because we were sort of trying to find the ideal use case that fits our mission as a company, but also gives the coin some kind of actual value, as not just like an asset that carries some kind of valuation, but as an actual utility itself. So we will be when we release our models, we will be using the coin sort of as a step tiered sort of mechanism for sort of gauging access, at least initially, to a lot of our product offerings. So token holders will be incentivized to have early access to our models, maybe even beta deployments prior to actual commercial deliveries. And this would include, large companies and stuff like this who want to get access to our stuff. And So that's something that I think is really important, that gives the token itself a clear connection to our business operations. It will be greatly integrated into our website. It will be sort of a access pass, if you want to think about that, for some of the inside track of what we're doing as we kind of develop our um, sort of, I want to call it uh, product delivery cycle, to include sort of more direct community development and intervention. So, and then going backwards from that, so yeah, the framework itself will be very useful to basically small to medium to even large businesses, because you'll be able to, at a cost that is, quite paltry compared to the current sort of market value of training these other um, learning systems, you'll get basically an equivalent system for a significantly smaller price. That having been said, our system is also capable of doing things that the other variants are not. One of the advantages of geometric learning are things like, learning with smaller data sets, much more advanced fine-tuning capabilities in terms of learning from, actual runtime usage. And when we actually finally release these models, and people have an opportunity to sort of experiment with them, I have some very optimistic views for where people will be able to go with regards to reinforcement learning, and our models, and other sorts of things like that. And then to go back even one step further than that, so in addition to, small and medium businesses for the first time really ever having access to, being able to train learning systems that rival the largest companies on planet Earth, that are purveyors of these AI systems, you'll also be able to use our models on various kinds of hardware, as I mentioned, prior to your question, that you would otherwise not be able to run an LLM on. So many people may know this, but I am sort of an embedded system specialist. My experience with AI is not really, well, I have a lot of cloud-based AI experience, obviously, but my sort of professional background is in embedded systems architecture. So sort of self-contained autonomous computing systems. And this is sort of the area I've been working in since about 2009. So one of the reasons why I incentivized myself to develop this approach to produce smaller footprint learning systems is simply so that I could run more advanced models on cheaper, more cost or more what do you want to say, lower overhead, less energy requirement sort of hardware. And that's, in my opinion, where the real value of our QLLM is going to come from, because you're going to be able to run, something like the equivalent of a 32 billion parameter LLM on something like your cell phone, because it's only going to take up the kind of space and resources of something like a 3.5 billion parameter LLM. So all of a sudden, embedded AI on devices becomes a lot better, and then we can sort of reconsider the relationship between cloud-based and embedded AI, because of course, even in our own offerings, our trillion parameter LLM that we're building, QLLM that we're building, will of course be a cloud-based service for almost everyone who's accessing it. Very few people outside of Tsotchke Corporation will have access to the physical computer itself. So I see sort of a future in which, like, really advanced embedded AIs running on low wattage devices are able to interface with these more advanced centralized AI cloud-based processes, and sort of have these multi-chain prompting systems, just to increase the sheer amount of intelligence available to to the consumer. So yeah, the essence of these upcoming deliveries is effectively we're going to democratize both the AI training process, but also the deployment process for intelligent machines. So hopefully you'll even be seeing, something like 20-year-old hardware running LLMs from Tsotchke in the near future.
Yeah, so I think, a lot of people probably ask, like, how is this not already a thing, right? Because you have all these companies that do have, many, many $1 million of funding, that are essentially trying to solve technological problems with brute force and money, which is great. Money does help you solve a lot of problems, but I think a lot of people are probably wondering, why this doesn't already exist, A, and B, what it is that you're doing that's going to allow and enable this QLM to exist at such a cost-effective scale that's going to enable all these other companies to build on top of it. I mean, I think that's ultimately what a lot of people are trying to figure out.
Yeah, to be honest with you, I kind of want to distance myself from the insinuation that like I'm doing something that's, somehow miraculous or impossible or something like this because frankly, um I think not that what we're doing is not important or world changing. It absolutely is. That's not what I'm saying. But this question comes up a lot like, oh, well, why isn't anybody else doing this? And the answer is quite simple. Like TensorFlow was written, almost a decade ago, not quite, but and it's a particular approach that people are familiar with. What we are presenting, this geometric learning approach based on, quantum circuits, is a totally new way of looking at learning problems. So I mean, number one, how many people working in deep learning are mathematicians? Like almost none of them. And then of the mathematicians and statistics who are statisticians who are working in this area, how many of them have commercial ambitions? So like a lot of the technology that we're implementing is in research papers predominantly and in materials that are otherwise you know basically still considered by some to be in the experimental sort of realm. But our kind of company ethos is sort of a union of engineering and theory. So our implementations, in a sense, are experiments, and our theoretical interests are engineering problems. So, I mean, again, I can't really tell you what the incentive is for any other existing provider of learning systems to want to like scrap everything from the beginning and like take a quantum geometric approach. I think it's extremely unlikely that many people would want to build a system literally from the ground up. Like I've heard some criticism that, oh, well, there's Cirque or there's Q Awesome, it's there are these other
Circuit Google, right?
Cirque is Google, yeah. And there are these other sort of quantum emulation frameworks or something, and that's all well and good, but we can basically do more or less everything that Cirque can do, but Cirque can't necessarily support, our kind of integrated, unified framework that's based around the geometric tensor. Like, I really want to stress that the tensor library is really two things. It's a high performance hybrid computing framework, but it's also a learning system in which the central object is this, particular thing. And most people um, in the learning kind of world are not even aware of the concept of what a quantum geometric tensor is because it's a concept from condensed matter physics and quantum field theory. So, but then again, the concept of tensors themselves effectively come from classical physics in the way that they've been implemented in these systems. So the idea of effectively porting concepts from, theoretical physics and adapting them for, consumer level technology is not exactly a strange thing. I mean, everybody has seen a CD player, I hope, or if you're too young for a CD player, maybe a flash drive or something like this at some point. These are all applications of, pretty much cutting edge quantum mechanical technologies that were repurposed for the consumer market. So the idea of taking sort of cutting edge quantum computing approaches and packaging them into a generic sort of user friendly learning system is itself a fairly significant like engineering contribution, let alone the fact that it unifies, all of these disparate areas like algebraic topology and singular learning theory and topological quantum computing and stuff like that. Anyone that's been paying attention to the timeline probably saw, some Google adjacent teams recently published some very promising information about anionic topological computation. So anions are the effectively the units of topological computation. If you want to think about that, they're like the braid units that are used as qubits in our system. And some of the most advanced multi-qubit systems that have been observed to date statistically have been seen in very recent history. Some of these papers were published no more than 2 weeks ago. So I really want to stress how cutting edge our library really is. Many of the concepts in the library are based on research papers that have come out in the last 9 months. And again, leveraging my own background as a quantum field theorist and systems architect. So what makes us uniquely positioned to make such a thing? I honestly can't tell you, and I don't really think that speculating about such things is really that useful for me, especially not from my ego's perspective. I try to maintain a sense of humility about these things. But I would say that I am uniquely positioned to want to build a system like this. It's also within my sort of both aesthetic and professional interest that the system has little to no external dependencies, which I think is, again, something that many larger or corporate software projects are probably not as concerned with long-term code rot problems like I am.
Yeah, I think, you kind of touched on something interesting there, which to me frames a lot of the confusion about, or even, headwinds that you've kind of faced since launching this thing, which is basically that, well, you really are doing something brand new. You're doing it in a different way, a more efficient way that isn't reliant on a lot of the other things that these other frameworks are reliant on. And so I think when you're building something that people just straight up don't understand, and something that is proprietary, it's inevitable that you're going to face some headwinds like that. I do think it's super interesting. Some of those articles that you've mentioned that have come out just within the past, 2 to 6 weeks. The timing on a lot of this stuff is not coincidental, and it does show that, in my opinion, your research is, not just on the cutting edge, but in the right place at the right time. So, that's interesting in itself.
Yeah, I mean, something that probably nobody knows except for maybe some of my very closest friends. I had a bit of an aha moment earlier this summer that sort of led to the development of this project. So, some of you know I have an association with a research organization called Plectics Lab. That was where I gave my talk on sort of topological quantum phases of matter related to topological quantum computing. Sort of covers the Berry phase, specifically key concept in my current geometric tensor library. But during the summer, we had many physics conferences that were held. So I had an opportunity to meet some of my personal heroes, such as Dr. Albert Schwartz and many other people like that. And what was interesting about speaking with Dr. Schwartz and some of these string theorists and sort of foundational physicists, whom my own research is based on, is like after having spoken to like 10 of these guys and sat through like 15 or so, 20 lectures, I came to the realization that my work is literally like in the lineage of these these individuals. So it's literally like one of the talks that Dr. Martinek gave. You almost could have started my topological computing talk right after it, or the same thing with, say, Dr. Schwartz or something like that. And that was really the first time in my entire life that I realized that my research wasn't just something that was like interesting to me personally. Like I sort of have a bit of a, auto fetishism or something with regards to my research interests. I sort of just study things that I find are interesting, and I never really sought out to like pursue something that I thought would have a lot of ambition, for development or for, anything like that. I was just studying stuff that I thought was interesting. And then so earlier this summer when I had this aha moment, I realized like this isn't just something that I'm studying that only appeals to me. I'm literally like pursuing the answer to a question that physicists have been asking for, on the high side, hundreds of years, but really since like the mid 1960s, with regards to, intersections of, say, string theory and quantum field theory and topology and stuff like that. Many of you realize that I'm a mathematical physicist, which means like I tend to think of the world more in terms of mathematical objects than, say, physical objects themselves. And so to find myself sort of at this intersection of, what I would consider to be like theoretical beauty, but then also this realization of its applicability and its value for, these important world transforming technologies. That was like a existential moment for me. So uh, the realization that the importance of my research goes far beyond just satisfying some interest of mine to solve a problem, and realizing that we could actually solve some of the hardest problems in the entire world using this pursuit. And I have no doubt that that sort of realization that we're really pulling on the thread of what may be one of the most important scientific realizations in at least in recent history, if not in the last 50 years, is right in front of us. And I think like that explains sort of some of the electric energy that people feel around the project and around my work and stuff, and maybe also explains why maybe we're subject to maybe unhealthy amounts of criticism that ordinarily would not have been sent in our way, simply because there are people that realize, what the ramifications of this work actually is. So, I mean, again, I find myself at an interesting nexus point because, on one hand, I am just a kind of an obscure, sort of humble researcher, and I don't really want necessarily to cause a lot of problems or to get a lot of attention or something like this. But on the other hand, the realization, kind of related to your last question, that I'm sort of uniquely positioned to make these contributions. So it it puts me in a very interesting situation that I've never really been in my entire life, and that's why I really have such an intense moral obligation to finish my work with the highest possible quality, with the highest possible efficacy, and deliver on not only everything that I promised, but untold things that I haven't even gotten to yet.
Yeah, I mean, it'll all come to the forefront here soon. I think obviously all of us that are a part of this space understand how fast things move nowadays. I think, there's a big topic in the last few weeks just about how fast people want to rotate in and out of positions and they don't want to hold things and whatever. And that's just it's kind of unfortunately programmed and coded a lot of us to think on such a totally different, time horizon than you would with any other type of technology, which we're kind of building things backwards here. Like the reality is like, this tech startup does have a coin attached to it. And I think ironically, which I've learned more recently, a lot of people in standardized AI, regular AI, and even in the science field really, really dislike crypto. And so from my perspective, I think that's where majority of our headwinds have come, is because people essentially want to write off what you're doing just because there's a coin attached to it. And they think that, there's certain intentions with that. And to me, that's okay, because we're actually going to be bridging that gap, and we're going to show a lot of people um, the reality of what it is that you're doing here. And I think that's what I'm most excited about. Like, there's so many things that I know that I wish we could tell people, but it just is going to take time. And I have to be patient with us sharing that information. But I see from the inside, like, just for perspective, like Tsotchke literally is coding like 16 hours a day. Like, this is all he's doing, is coding and working. But a lot of this stuff can't be shown along the way, because it's just, he's writing lines of code. It's like the initial release for your Tensor library was like over 100,000 lines of code, and it doesn't mean anything to anybody until that code does something. And so, the fact that the first release already showed that a lot of your claims were exactly as you said and or greater, that's just going to continue to keep happening here. I'm super excited about the future. We're approaching an hour here. We don't need to go too long, because I want to do these more regularly and talk to people more regularly about what we're doing. But just to be totally authentic with everybody that's here with us in this space right now, like, this is something where, even if you don't have exposure to the coin, like, the support of a project like this and just being around and telling people about what it is Tsotchke's doing is what's going to help and move things along. Like, we're not even asking people to support in any way besides, follow along what we're doing, like, be interested in this. This is cutting edge technology, and that's why I got into crypto, was for access to stuff like that. And this is exactly the kind of thing that people should be looking for.
Yeah, I mean, like, it's really hard for people to sort of wrap their minds around the fact, because, I mean, a lot of the criticism that I get is like, what kind of serious scientist launches a coin? And the answer is that, I mean, generally speaking, they don't. I mean, that's a fair criticism, but the problem then comes when people sort of project their own sort of desires and ambitions for the world onto me and my project. And unfortunately, that just simply isn't the reality of the situation. I value this token so very much. It's not something that I see as a, I don't know how to say this any more emphatically. Like, the way every single person in crypto thinks about coins, I do not think about this project or any other project. I'm similar to some of my compatriots in the development world, in that I personally don't have a lot of interest in, cryptographic currencies or anything like that, in other than, things like Bitcoin and stuff like that. I'm not a trader. I've never been a trader. I never will be a trader. I don't gamble, so to speak. And I really stress that the value of the coin is really not what a lot of people who sort of try to paint nefarious views onto the project. They say things like, "Oh, it's just going to be some sort of a pump and dump or something." Never mind the fact that the coin has been pumping numerous times in the last 2 months, and we don't touch it. It's really a community-driven marketing effort, and that's why tying the utility of the coin to our actual product offerings themselves, I think, is imperative, in terms of, establishing to the greater Solana community that, yeah, sure, this is something that you can trade, and it's just part of the normal cycle or something like this. But it's also something that has value outside of just, what it's worth looking at the chart at any given moment or something like that. And again, I want to be very clear about this, that the community that rallies around this project via the coin are what make all of our marketing and promotion efforts possible. So the support of the people who put their actual time, money, and interest in the project is predominantly what gets us the attention that we're able to get. So sort of the reward for people investing in the project at the early stage is sort of helping us to achieve a higher profile, which really assists in legitimizing ourselves in the industry and getting our offerings out to the appropriate parties and getting the media cycle in our favor and stuff like that. It's really like I really see the meme coin aspect of the currency itself as being the extension of sort of the social marketing aspect of the coin itself. That having been said, so I'm a major supporter of what is happening in the coin world and in cryptocurrencies in general. I'm a big fan of Web3 and what I call Web7 or Web4 or whatever. These upcoming sort of technologies that will even be built off of, say, the shoulders of things like NFTs and the blockchain and stuff like that. I'm a big supporter of all this stuff. It appeals to me mathematically. It appeals to me politically. It appeals to me aesthetically as somebody who supports decentralized art in general. But coin things aside, a lot of people unfairly attack my work and unfairly attack the project on the basis of what their basic prejudices are against anyone even remotely associated with the crypto space, which again is hypocritical on the face of it. So it's not even really worth addressing. And it's not exactly ethically consistent to apply one's framework in such a way where you tend to penalize things that you have within reach, like say a small new emerging project versus say much larger examples of say nefarious or wrongdoing associated with some of these concepts. All of this just to say, I I I would say that I'm an abnormally sensitive person versus most people. I tend to like wear my heart on my sleeve, and I tend to be very unguarded about things like my affections and my the way that I treat people and stuff like this. And I've experienced some very ugly things over the last couple weeks, specifically that really don't have anything to do with my research or what I'm building, attacks on my person and attacks on the project and stuff like this. And I understand that this is just sort of how society is, and this is sort of how the project is. And some people sort of try to make me feel better by saying things like, well, you're only getting attacked so much because your work is so important or something like this. But to be completely honest with you, like it's it's frankly embarrassing to see how people behave in this space and sort of tangential to it. And I want to let all of you know, beyond any shadow of a doubt, that my work is absolutely legitimate, and I am fulfilling every single thing that I say. I am a very serious academic and a very serious researcher, and despite any claims to the contrary or any superficial criticisms that have been made of what I am doing, we are delivering extremely high quality, cutting edge, technologically superior products to the market. And this will happen regardless of any presumption of dignity or care for my person by the greater market or by the greater society as a whole. So I do appreciate that this is an opportunity to sort of build character by walking through the flames, so to speak. But I must lament at how unnecessary it has been to denigrate me for effectively no reason. And I want you to know that every single one of these people will be shown to not only have been in the wrong, but to have been not acting under good faith from the beginning. So I have no interest in attacking anyone else. I support everyone's projects. I support the entire ecosystem, and I support anyone's right and privilege to make a project for themselves and promote it. And if I see it in the space, I will lend my positive energy to it, regardless of who it belongs to, as long as the project is founded on goodwill and hopefully some level of altruism. But this is really not a platform for me um, to do anything other than be a beacon of love and support for the entire community at large. And while I'm not necessarily the most strong person in the entire world when it comes to things like guarding my feelings and things like that, I am a very genuine person, and you can always trust that I will be leading with my heart 100% of the time. So to all those who have found legitimate criticism in what we're doing, we will address all of those concerns as timely as possible, and make sure that we are, meeting your criterion for successful, well-meaning project in the consumer tech space. And for those of you who wish ill upon me simply for the sake of crushing something beautiful, I'm very sorry to disappoint you, but I'm going to continue my work.
Yeah, that was really well said. I think that's about that about sums up anything else we could say today. We should end it there. We're in a really good spot. We're going to have another one of these next week with more updates and more talks. And I think also next week I'd like to aim to do one with the Q&A. A lot of people have questions, and I think we're to the point now where a lot of people understand enough of what it is that we're trying to accomplish here that we can have some educated questions and see what people have to say and what they think about what we're doing, or criticisms or whatever. We're always open to that. We're trying to be the best that we can. And one thing that you said was living up to people's criteria. I can promise you that our criteria that we are trying to live up to is higher than anything else that anyone else is trying to hold us to. So we will continue to deliver. We appreciate everybody for joining us today, and until next time.
Thank you all very much for coming. As Zach said, we will be doing these weekly. I'm going to try to throw in a couple spontaneous pop-up spaces every now and then as well, but look forward to regular sort of town halls. I think we're going to consider this to be something of a Tsotchke fireside chat series. So we'll figure out the actual scheduling as we go on. But look forward to that. And until next time, my friends, God bless you all. See you again.